Hi friends, welcome to my channel. Before going to the video, those who are not subscribed our channel, subscribe it and also click the bell button. In this video, we are going to see about phase lock loops. These phase lock loops are widely employed in radio, telecommunications, computers and other electronic applications. A phase lock loop is a control system which matches the phase of the output signal with the phase of the input or reference signal. The phase lock loops are closed loop feedback control systems and they consist of both analog and digital components to reduce any phase error that occurs. The main purpose of a phase lock loop is to synchronize the output oscillator signal with input or reference signal. When the phase difference between the two signals is zero or constant, then the system is said to be in locked state. In addition to synchronizing signals, phase lock loop can also track an input frequency, or it can generate a frequency that is multiple of the input frequency. Now let us see the basic components of phase lock loop. It consists of a phase detector, a low pass filter and a voltage controlled oscillator. The block diagram of the phase lock loop is shown in the figure. Here the input to the phase detector are reference signal and output signal from the voltage controlled oscillator. This phase detector detects the phase difference between the two signals and it generates an error signal proportional to the phase difference. The error signal is then passed to the low pass filter where the high frequency noise components are removed and it generates a steady voltage. The output from the low pass filter is fed to the voltage controlled oscillator for frequency correction. Now let us see the working of phase lock loop in detail. First, the phase detector. The phase detector is also called as phase comparator and it is an essential element of phase lock loop. This phase detector compares the phase of the output signal from the VCO with the reference signal. It then generates an error signal proportional to the phase difference between the two signals. Generally, an analog multiplier is used as a phase detector. At radio frequencies, balanced mixer is used as a phase detector. For digital signals, we can use XOR gate or phase frequency detector as phase detectors. Next is low pass filter. The error signal from the phase detector is given as input to the low pass filter. This error signal is basically a DC voltage. This low pass filter removes the high frequency noise components from the error signal and generates a steady DC voltage. Next is voltage controlled oscillator. The input to the voltage controlled oscillator is the steady DC voltage from low pass filter. Here the input signal will be directly proportional to the output frequency of the voltage controlled oscillator. In the VCO, the input and output frequencies are compared and adjusted through the feedback loop until the output frequency is equal to the input frequency. Thus, it maintains the same phase or constant phase difference between the input and output signals. The phase lock loop operates in three stages: free running stage, capture stage and phase lock stage. First is the free running stage. When no input voltage is given to the phase lock loop, then it is said to be in free running stage. Next is the capture stage. When an input voltage is applied to the phase lock loop, the frequency of applied voltage to the VCO changes and it produces an output frequency for comparison. Then it is called as capture stage. Next is phase lock stage. When the voltage control oscillator frequency is same as the input frequency and there is no phase difference or constant phase difference between the two signals, then the phase lock loop is said to be in lock stage. Next, let us see the lock and capture range of phase lock loop. In the figure, F0 is the free running or center operating frequency of the voltage controlled oscillator, and it is given by F0 is equal to 0.3 divided by R1 into C1. Here R1 and C1 are the resistance and capacitance value of the oscillator. Next is the capture range. The range of input frequencies around the voltage controlled oscillator center frequency onto which the loop will lock when starting from the unlocked condition is called as capture range. The capture range depends on the characteristics of the low pass filter. The capture range is generally lower than the lock range. The capture range is an important phase lock loop parameter because it determines whether the lock condition can be established or not. The capture range of the phase lock loop is given by Fc is equal to plus or minus 1 by 2 pi square root of 2 pi Fl divided by R2C2. Here Fl is the lock range. R2 and C2 are the resistance and capacitance value of low pass filter. Next is the lock range. It is the range of input signal frequencies over which the loop remains locked after capturing the input signal. This lock range can be limited either by the phase detector or the voltage controlled oscillator frequency range. The lock range of the phase lock loop is given by Fl is equal to plus or minus 8 into F0 divided by V. Here F0 is the free running or center frequency of the voltage controlled oscillator and V is the applied voltage. Next is the applications of phase lock loop. These phase lock loops are mainly used for synchronizing purposes, radar synchronization and communication. Next, they are most widely used in frequency synthesis. Hence, these phase lock loops are also called as frequency synthesizers. They are also used in motor speed control systems. They are used for jitter and noise reduction, skew suppression, etc. They are also used in demodulating circuits of FM, that is frequency modulation, frequency shift keying, single sideband, quadrature amplitude modulation, quadrature phase shift keying. They are used in time to digital converters and also to clock recovery. They are also used to recover clock from a serial data bit stream. Phase lock loops are also used in microcontrollers to manipulate the frequency of clock signals. Next, let us see the previous year questions. First question was asked in June 2015. It is matched the following type. First, analog to digital converter. We know that successive approximation is a type of analog to digital converter. Next is the emitter follower. For this, impedance matching is the valid one. Next is Schmitt-Trigger. We know that it is a comparator with hysteresis. And the last one is phase lock loop. We know that voltage controlled oscillator, that is VCO, is a component of phase lock loop. So option B is correct. Next, second question. This question was also asked in June 2015. The voltage controlled oscillator VCO is used for first one, voltage to frequency conversion, B, frequency to voltage conversion, C, voltage to voltage conversion, D, frequency to frequency conversion. We know that in voltage controlled oscillator, according to the applied voltage, frequency correction is done. So voltage to frequency correction is the correct one. Answer A is correct. Third question. This question was also asked in June 2015. The phase lock loop is in free running state when option A, input applied is equal to the output voltage. Option B, input is twice of the output voltage. Option C, input is 1/2 of the output. Option D, no input is applied. know that the phase lock loop operates in free running state when no input voltage is applied. So option D is correct. Next question, fourth one. This question was also asked in June 2015. A phase lock loop consists of option A, high pass filter, option B, a band pass filter, option C, a low pass filter, option D, an all pass filter. We know that the phase lock loop consists of a low pass filter, hence option C is correct. Next, fifth question. This question was also asked in June 2015. A phase lock loop is used for demodulation of which of the following signals? Option A, amplitude modulated signals. Option B, frequency modulated signals. Option C, pulse code modulated signals. Option D, FSK signals. If we see the application of phase lock loop, it is used for demodulation of frequency modulated signals. Hence, option B is correct. Next, sixth question. This question was asked in June 2019. In case of a monolithic phase lock loop, the equation of free running frequency of the voltage controlled oscillator is option A, F out is approximately equal to 4 by 1.2 R1 C1 Hz. B, F out is approximately equal to 1.2 R1 C1 by 4 Hz. C, F out is approximately equal to 1.2 divided by R1 C1 Hz. D, F out is approximately equal to 1.2 divided by 4 R1 C1 Hz. We know the formula for free running or center frequency of voltage controlled oscillator is F naught is equal to 0.3 divided by R1 C1. Here 1.2 divided by 4, which is equal to 0.3 divided by R1 C1. So option D is correct. Next, question number 7. This question was asked in December 2019. Which one of the following options give correct relations of center frequency F out and lock range FL of your phase lock loop? Option A, F out is approximately equal to 4 by 1.2 R1 C1 Hz. FL is equal to plus or minus 4 F out by V Hz. Option B, F out is approximately equal to 1.2 R1 C1 by 4 Hz. FL is equal to plus or minus 4 F out by V Hz. Option C, F out is approximately equal to 1.2 divided by R1 C1 Hz. FL is equal to plus or minus 8 F out by V Hz. Option D, F out is approximately equal to 1.2 divided by 4 R1 C1 Hz, FL is equal to plus or minus 8 F out divided by V Hz. We know that the formula for center frequency is F out is approximately equal to 0.3 R1 C divided by R1 C1, that is 1.2 divided by 4 R1 C1 Hz, and the lock range FL is equal to plus or minus 8 into F out divided by V Hz. Hence option D is correct. Next, 8th question. This question was asked in November 2020. Which of the following is not a component of basic phase lock loop? Option A, phase detector. Option B, voltage controlled oscillator. Option C, Schmitt trigger. Option D, low pass filter. We know that the components of phase lock loop are phase detector, voltage controlled oscillator and low pass filter. Schmitt trigger is not a component, hence option C is correct. Thanks for watching the video. For more videos, don't forget to subscribe our channel.